Hello guys, you're welcome to my YouTube channel. And guys, in today's video I want us to go and look at how to find the turning points. Remember, we are dealing with the topic of calculus. Previously I was talking about the x-intercepts. Now I'm talking about how to find the turning point. So the focus in today's topic is about the turning points. How can we find the turning points of a cubic function? Not just any turning point, but the turning point of a cubic function. And this is our equation: x cubed minus 4x squared minus 11x plus 30. And we want to find the turning points of a cubic function. Now guys, this is my advice. Whenever you are looking for the turning point of a cubic function, I advise you to derive. So the key concept that you should know is that I have to derive. If I want the turning point of a cubic function, I have to derive. I don't know how important is it. I don't know how can I say it, guys, for you to recognize that is very, very, very important. Simply, you have to derive. If you're looking for the turning point, guys, please derive your function. So you say dy over dx equals to. So you are simply saying, I'm going to derive my function dy over dx. So you derive x cubed. What is the derivative of x cubed? Is 3x squared. And how did I find that the derivative of x cubed is 3x squared? When you derive x cubed, you always go for the exponent, guys. The exponent is 3. So you take the exponent, you multiply it with the coefficient of x. So the exponent is 3. What is the coefficient of x? It's 1. So you say 3 times 1, you write this 3. You bring down the variable, it's x, you write it as x. Now you go back to the exponent, you subtract it by 1. So you say 3 minus 1 is 2. So the derivative of x cubed is 3x squared. What you guys think will be the derivative of negative 4x squared? Remember, you have to start with the exponent, multiply it with the coefficient of x, the number before this x. So you say 2 times negative 4. You get negative 8. Then you write the variable as it is. Just write the variable as it is. To your exponent, subtract 1. So our exponent is 2. We subtract 1. We're going to be left with 1. So the exponent is 1. I won't write the exponent of 1, guys. Or let me just write it and say negative 8x to the exponent 1. But in the exam room, don't write this exponent 1. I just wanted you to have an idea of what is the derivative of negative 4x squared. Now let's derive in negative 11x. What is the derivative of negative 11x? The derivative of negative 11x is in negative 11. What is the derivative of 30? 30 is a constant number, guys. So the derivative of a constant number is 0. So we say the derivative of 30 is 0. The derivative of negative 11x is negative 11. So guys, it's very, 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 very important that you know how to derive. So guys, I'm going to derive for you 6x cubed. What is the derivative of 6x cubed? I said you always start with the exponent. Your exponent is 3. You multiply it with the coefficient of x. So the number before x is 6. So you say 3 times 6. 3 times 6, how much is 3 times 6? 12, 18. You write the variable as it is, x. What do you do to the exponent? Subtract it by 1. So you say 3 minus 1. So the answer is 2. So the derivative of 6x cubed is 18x squared. You should know how to derive. What is the derivative of 4x? Simplest expression to derive the derivative of 4x. The derivative of 4x is 4. You guys, you should know how to derive, because 4x, this is a number, or let me say it's x with a number. So to derive this kind of expression, you just take, if it is 4x, you just say the derivative is 4. So the question is, what is the derivative of negative 11x? The derivative of negative 11x is negative 11. What is the derivative of 30? The 30 is just a number, so the derivative of 30 is 0. It's very, very important, guys, that you know how to derive. But when you derive, work with your exponent. The first thing that you start with is the exponent. You go to the exponent, you multiply it with the coefficient of x. So you say 3 times 6, it's 18. You get 18. You just write x as it is, xx. What do you do to the exponent? Subtract it by 1. So the answer is 18x squared. Guys, you have to know how to differentiate. What I'm doing, I am differentiating. So when we calculate the turning point, you have to remember, you have to differentiate. Let me write here, let me write something like a circle, and I say to find the turning point. To find the turning point, you have to differentiate. It's very, very important, guys. You have to differentiate. So to find your turning point, you just have to differentiate, guys. You say dy over dx. Know that one, don't forget it. To calculate the turning point, you just have to derive. So you differentiate your function. So hopefully you guys, you know how to differentiate. So now I was differentiating this function, x cubed minus 4x squared minus 11x plus 30. I was differentiating because I am looking for the turning point. Now you say dy over dx, you put it 0. Why do you say dy over dx 0? Simply because you are looking for the turning point. There is something that you should know, guys. At the turning point, dy over dx is always 0. So whenever you see the turning point, you should know that dy over dx is 0. So after you say dy over dx, you put it 0 because our focus is on the turning point. So you say 0 equals to 3x squared minus 8x minus 11. So remember that one. The first thing you differentiate. Secondly, you say dy over dx is 0. Now what are you going to do? You say 0 equals to, because this is 3x squared minus 8x minus 11. This is in a form of a quadratic. So what you should do to a quadratic function, guys, you should factorize it. So you should think of factorizing. You open two brackets, you are prepared to factorize. You say 3x x. You look for the factors of 11. You say 11 and 1. You put negative, the bigger number takes the sign in the middle, and you put positive. So what are the values of x? We know that after factorizing, we can find our values of x. So the value of x is 11 over 3, or the value of x is negative 1. So these are the x coordinates at the turning point. We know that at the turning point, we have 11 over 3 the x turning point, one of the x turning point is 11 over 3, and another x turning point is negative 1. So guys, there is one of the interesting question here. Still on the turning point, I want us to remember something. Let's go back to what we call a quadratic. Let's go back to a quadratic a little bit. We'll go back to our cubic function. What you have to remember is that in a quadratic function, we have only one turning point. In a quadratic, you are going to have one turning point. So this is the turning point of this quadratic graph. And this is the turning point of this quadratic graph. So in a quadratic function, you only have one turning point. So it means that even the x turning point is only one, and the y turning point is only one. So at this turning point, you will just have, let's say, the turning point of x is 6, and the turning point of y, let me just say, it's 7. So this will be the only turning point that you have. Our turning point in a quadratic will just be one turning point of x and one turning point of y, meaning that the x turning point will only be 1 and the y turning point will only be 1. But in cubic, you have to recall that cubic can be of this nature. So guys, in cubic, the turning point of x, we have got the turning point of x here. Let's say this is the x turning point, and we've got another turning point of x here. So in a cubic function, guys, you have to remember that we have got two x coordinates of the turning point. You have the turning point of x on this one, and you have got the turning point of x on this one. So a cubic function, it has two turning point of x because of the nature of a function. So remember that you should always be able to differentiate between a quadratic and a cubic. In a quadratic, we've got only one turning point of x, but in a cubic, we've got one turning point of x and another turning point of x. So in a cubic, we've got two turning points of x. No wonder, guys, no wonder when I was looking for the turning point of this function, that one of the turning point of x is 11 over 3 and another one turning point of x is negative 1. Simply because in a cubic function, we have got two turning point of x. So guys, remember, so let's take it step by step. The first thing that you do, this is your function. The first thing that you do to your function, you derive it. After you derive your function, you say dy over dx, you put it 0. Now, this is what you should do. You should factorize this quadratic function. You should always remember that when you calculate the turning point of x, you have to factorize. You are going to have two turning points. One of the turning point of x is 11 over 3, and the other turning point of x is negative 1. So here it's a question. These are the turning point of x. How can I find the turning point of y? To find the turning point of y, you have to go back to the original function. So the original function was x cubed minus 4x squared minus 11x plus 30. Yes, this was the original function, guys. The original function is x cubed minus 4x squared minus 11x plus 30, or one can say f at x equals to. So this is my original function. So to find the turning point of y, I will say f at x equals to, where I see x, I put 11 over 3. Why 11 over 3? because the turning point of x is 11 over 3. So I go back to the original function. On this original function where I see x, I put 11 over 3. So it's going to be 11 over 3 cube minus 4 into 11 over 3 squared minus 11 into 11 over 3 plus 30. Okay guys, wherever there is x, I was substituting it with 11 over 3 to find, so that I can find the turning point of y. So the question is, when the turning point of x is 11 over 3, how much is the turning point of y? And what do? I go back to the original function. I substitute the turning point of x, 11 over 3, to find the turning point of y. The answer should be, if you press it on your calculator, the turning point of y, you press it on calculator, you find how much is the turning point of y. I think it's negative 14,8. I think it's negative 14,8. But guys, confirm that one on calculator. When the turning point of x is 11 over 3, what is the turning point of y? I don't have Casio with me, but in this case, when we pair the coordinates, we are going to say 11 over 3 and negative 14,8. So we are saying when the turning point of x is 11 over 3, the turning point of y is negative 14,8. So then you go back to the original function again. You calculate for the turning point of y when the x turning point is negative 1. So you ask yourself, when the x turning point is negative 1, what is the turning point of y? So you go back to the original function. I will do it here. The original function is x cubed minus 4x squared minus 11x plus 30. So I say when x is negative 1, what is the turning point of y? Plus 30 is positive 30. The last value is positive 30. So you press negative 1 cube, negative 4 into negative 1, negative 9, and you see how much is the turning point of y. So this one, I doubt, even if I don't have a calculator, this is negative 1, negative 1, negative 4, negative 3, negative 3, plus 11, 8, 38. So I see the turning point being 38. So we're saying when the turning point of x is negative 1, the turning point of y is 38. Confirm that one with a calculator, guys, because I'm not using a calculator. I'm just doing everything from my mind. So you have to check it with a calculator. So this is all about calculating the turning points. So finding the turning point of a cubic function should not be difficult. So I have a question for you. Let's say they give you a sketch, and they give you a sketch like this, and they say find the coordinates of A and the coordinates of B. What are you going to do, guys? To find the coordinates of A, you look for the turning point. The coordinates of A is the turning point of x and y. So you look for the turning point, and you also look for the turning point, because they might not say to you find the turning point. They might say find the coordinates of A and find the coordinates of B. You have to know that the coordinates of A and B are our turning point. So guys, hopefully you know how to find the turning point. Let's summarize what we were doing. Step 1, I said you have to derive. Don't forget that when you are looking for the turning point, the first thing that you do, you derive. Step 2, after you have derived, you say dy over dx is 0. So you put dy over dx 0, guys. Where you see dy over dx, you put 0. Step 3, factorize. After factorizing, you will know the turning point of x. So the last step, substitute sub on original, substitute on the original function. So remember those steps that we follow when we look for the turning points of a cubic function. It is not difficult. Derive. So the key concept that I will say, do not forget, is to derive. Because after you deriving, you will just have to know that dy over dx is 0, you factorize, or you use a quadratic formula. If you don't want to factorize, guys, you use a quadratic formula, then you substitute the value of x on the original function to find the turning point of y. Thank you so very much, guys, for watching my YouTube channel. And here, guys, for now, I'm still laying basic. The time is coming where I will be answering the previous question papers. This is more grade 12 mathematics. Guys, hopefully you have enjoyed this video lesson. Even though I'm still facing some difficulties because of the system that I'm using, everything here, I'm just doing it cheap. I'm using my Samsung Z4 phone. Guys, just bear with us and try to learn as much as possible. Thank you very much. Make sure that you subscribe and comment, because commenting, guys, is very, very helpful for us as those who are tutoring maths on YouTube. Because when you comment, guys, you can comment positively or negatively, but just be honest with your comment. When you comment negatively, we will be able to rectify our mistake. If you comment positively, you are encouraging us. Thank you so much. God bless you. Hopefully you will know how to find the turning point of a cubic function.